When working on the Cartesian plane, we can find the distance between any 2 points by using the formula distance is equal to y2 minus y1 squared plus x2 minus x1 squared, all under a square root. Here, x1 and y1 take on the x and y coordinates of one point, and x2 and y2 take on the x and y coordinates of the other point. It does not matter which point you assign as point 1 and which point you assign as point 2. The distance will be the same regardless. Let's look at some examples. The diagram shows the line segment AB. Calculate the distance between point A and point B to 2 decimal places. As we can see from the diagram, point A has coordinates 1, 1, and point B has coordinates -1, 2. Let's say that A is our first point and B is our second. Now we can take these values and put them into the formula. So we say AB is equal to the y coordinate of B, which is 2, minus the y coordinate of A, which is 1, close the bracket, squared, plus the x coordinate of B, -1, let's open a bracket, minus the x coordinate of A, which is 1, close the bracket, squared, all under a square root. Now we can simplify the terms in the bracket. 2 minus 1 gives us 1, and 1 squared is simply 1, plus -1 minus 1 is -2. We can put this into a bracket, square it, and we put everything under a square root. Now we have 1 plus -2 squared, which is +4, under a square root. And finally, we can say 1 plus 4, which gives us 5, under a square root. Now, the question asks us to put our answer to 2 decimal places. So let's open our calculator and we can say square root 5. Let's put this in decimal form and we get 2,236. Let's round this off to 2 decimal places and we see that AB is equal to 2,24. 2 decimal places tells us that we can use our calculator to find any distance, and you can put this equation straight into your calculator. But it is important to understand how we use this formula and each step we have to take. So let's look at another example. Find the distance between point C, -4, -2, and point D, 8, 3. Here we don't have a diagram, and you can draw a quick sketch if you want to, but a diagram is not necessary. We can simply use the formula up here to find the distance between any 2 points. In this case, let's say that C is our first point and D is our second. And now we can put these coordinates into the formula. So we say CD is equal to the y coordinate of D, 3, minus the y coordinate of C, so we say minus -2, in a bracket squared, plus, open a new bracket, the x coordinate of D, which is 8, minus the x coordinate of C, which is -4. So we get 8 plus 4 squared, all under a square root. Now let's simplify the terms within the bracket. 3 plus 2 gives us 5, so we get 5 squared, plus 8 plus 4 is 12. Put this into a bracket too, squared, all under a square root. Now let's square our brackets. 5 squared gives us 25, plus 12 squared is 144, all under a square root. 25 plus 44 is 169. We put this under a root. Now we can open our calculator and we say the square root of 169 is equal to 13. This means that the length of CD is 13 units. Now 169 is a square number, so its square root, 13, is a whole number. But what if the value under the root isn't a square? The only way to find the value of the root without too much trouble is to use a calculator, unless we leave it as it is. Find the length of PQ if P has coordinates 2, 7 and Q has coordinates -3, 5. Leave your answer in surd form. Now a surd is a value underneath a root sign. So in this case, we can leave our final answer in simplified form underneath the root sign. Let's find the length of PQ. Let's say that P is our first point and Q is our second. So now we can say the length of PQ is equal to the y-coordinate of Q, which is 5, minus the y-coordinate of P, which is 7, close the brackets, squared, plus the x-coordinate of Q is -3. Let's open a new bracket. You see -3 minus the x-coordinate of P, which is 2. Close the bracket, squared, all under a square root. Now in our first bracket, we have 5 minus 7, which gives us -2. Let's put this into a bracket, squared, plus -3 minus 2 is -5. Let's put this into a bracket as well, squared, all under a square root. -2 squared gives us 4, plus -5 squared is 25, all under a square root. 4 plus 25 gives us 29, and we can put this under a root as well. 29 is not a square, so 29 under a root is a surd, and we can leave this as our final answer. Let's do one more example. Find the distance between point S, -15 and -2, and point T, 25, 7. We can use a calculator for this question, but before we do, let's input the coordinates into the formula. Let's say that S is our first point and T is our second. So now we can say the distance ST is equal to the y-coordinate of T, 7, minus the y-coordinate of S, -2. So we say minus -2 becomes 7 plus 2 in a bracket squared, plus the x-coordinate of T, 25, minus the x-coordinate of S, -15, and this becomes plus 15, close the bracket, squared, all under a square root. Before we use our calculator, let's simplify the numbers within the brackets. 7 plus 2 gives us 9, so we get 9 squared, plus 25 plus 15 is 40. We say 40 in the bracket squared, and we put all of this under a square root. Now we can open our calculator, and we're going to say the square root of 9 squared plus 40 squared is equal to 41 units. We can write this down as our answer.